Hello and welcome, this is Elliot Rathbone. Welcome to the GTK4 / GObject tutorial continuation. Today we are going to talk about GTK tree expanders. This was a request I've gotten a couple of times actually, and at first I thought, why would somebody specifically request this? But the more I looked into it, the more I realized it actually is a little bit hard to wrap your head around. And at the same time, it also allows us to continue our discussion in list models and all those weird and wonderful things. And so let's just jump right in. One thing I will say is that I'm kind of diving into this quite a while after I actually wrote the code for these demos. So I feel like in some ways it's a good thing, and in some ways it's a bad thing. It's a good thing in the sense that I may be just as confused as you guys are when I'm reviewing this, and so it might help me relate better to some of the initial hurdles in terms of knowing how to do this stuff. So let's jump in. We've got 4 different demo programs here. Let's make LV1 to show you what our first one will look like. Essentially, what you get with a tree expander is you get this arrow guy on the left-hand column, and as you expand within the column, you can get sub-items to come out of it. So you got foo and bar, and each of the foo and bar give you sub-foo and sub-bar. Then this is the first demo that we will look at. So it looks pretty simple, but there's quite a lot to it. So let's take a look at the .c file. There's no UI file associated with this first demo, but then the subsequent ones will have UI files. And so we start out with our main function. It creates via the activate callback a scroll window, which plops, it is plopped rather into our window, and then we go ahead and add a list view to the scrolled window. So the tree expander goes into the list view. And what happens is when you create the list view, we're going to again create a list store. And that list store is going to be created the same way that we always did before. And we're going to, for the purpose of this example, use a string object as our G type for the list store. Okay, that's fine. So, but then you have to go ahead and create what's called a tree list model in order to actually put that into the list view, in order to put the tree expander rather into the list view. And so the difficulty with this is that the tree list model constructor takes a lot of parameters, and you need to instantiate certain things that are not GObject properties. And so I don't know of any way that you can actually create a useful tree list model within an UI file. And so there's a certain point, unlike vanilla list views and column views, where you can use UI files to do almost all the heavy lifting, you do have to instantiate the tree list model with code. And this is the function that you use in which to do that. It takes a lot of arguments. So first it takes a root argument, which will be the list store that will have our string objects in them. And then, so again, looking ahead a bit, you're going to have to think to yourself, there's got to be a way to then go ahead and create sub items based upon the data that is in that initial list store. So just keep that in the back of your mind. That's the first argument. The second argument is something called a pass-through. And I have to be honest, to this day, I've been scratching my head and I still don't quite understand why you would ever want to have true passed to this item. It says, the documentation says, if false, the glist model functions for this object will return custom GTK tree list row objects. Okay, but we want that. And if true, the values of the child models are passed through unmodified. I don't really know what that means. We want these GTK tree list row objects to be created, and so we're going to pass false. If somebody in the comments wants to tell me when you would use true, please do so. I may also ask the author of this API to tell me when you would ever use pass through as true. We're going to use false. Auto expand, we're going to set to false. That just means do the arrows get expanded on their own or not. That's not a big deal. And then you need to pass it something called a GTK tree list model create function. That's a bit of a mouthful. But if we go to the documentation, let's do this real quick. We'll come back to that. What it is it's a glist model creator that takes your guy, right, from the root list store, and then it either returns or doesn't return a list model of its own. And if you return null, you're telling it this is the end of the line for what's going to be expanded from the tree view. And so keep that in mind. We'll look at that in a moment. User data is null. Destroy notify is null. Why would you want the gdestroy notify? I don't recall. Let's check the documentation. Destroy notify. Oh, I see. That's the user destroy function. So if we had user data, this would be the function that you want to pass to destroy the user data. Okay, so you see this is why it's good that it's been a while since I've looked at this, because it's not just so obvious. I had to look it up. There you go. All right. So kind of like we did before, we need to use an actual selection model as opposed to a raw list model to pass to the list view that's created. Same as before, the factory, we're going to use a create factory function. We'll look at that in a moment. And then we add stuff to store, and we create the list view. So let's look at these things one by one. Let's take a look at the create factory function. All right. All we're really doing is the setup and bind the same way that we did before, so that's fine. Add stuff to store. See, we're not adding all the sub foo and the sub bar stuff. We're just adding the strings foo and bar to the list store, the base list store. So then the question becomes, what do we actually do to then what do we then actually do to create the sub items? Well, we now look at our creator function. Like I said, it returns a glist model of its own. It takes the item itself from the list store, and then we go ahead and create a new list model, or list store, really, that will actually act as a list model. And if in comparing the strings we find that we don't have sub hyphen at the beginning of it, we're then going to create a new list store, and then that list store will add sub foo and sub bar if it does not have the sub hyphen at the beginning of it, which we know that to be true because we've added only foo and bar. So both then, foo and bar, should then give us a sub foo and sub bar sub list models that are then returned. So that's fine. Factories created the same way, like I said before. We already looked at that function. Now the bind callback of the actual list view function, right? So the list item that we get from the bind callback will be a special type of widget called a GTK tree list row. right? And we can then use GTK list item get item, and we know that the ret val will be of this type. And we know as well that when we grab the object type from the list item, it's going to be a string object. And we know that the child of the list item is going to be what's called an expander. And so then what you then go ahead and do is you set the list row of the expander to be the row that we obtained from the actual list item. And then we go ahead and we set the text to be from the item of the string object that's grabbed from the item. And so it's either going to be the foo, the bar, or the sub foo and the sub bar, depending, right? And then the setup callback, maybe we should have looked at that first, but it just creates a GTK label either way for any of these items, right? So again, we run it, and this is what we get. And recall as well that all the code will be on the GitLab repo. Link will be in the show notes. So, like I said, when you're creating when you got the function to create these sub list models, it can actually have a recursive effect, because if you don't return null, then it will keep creating list models. So one thing that we can do just to illustrate that is if we don't do the string comparison in this particular case, and we just say, you know, regardless of what the result of the string, regardless of what the string contains in the string object, just keep creating list models, basically. Don't check and return null if it doesn't start with sub. If we just comment this out, what we might then expect to happen is just to have an endless supply of these sub foo and these sub bars being created. And that is indeed what happens if we now run this guy here, LV1. We expand foo, we got a sub foo, which itself expands to sub foo and sub bar, which we can just keep doing and doing and doing forever and ever and ever and ever, which obviously is stupid, but that's the way that it works, because now at no time are we returning null. So you create these list models on the fly, right, with the tree, the tree list model create function. And so we have to stop it from doing this by returning null at some point. And again, for this silly example, we just do that when we don't see sub hyphen at the beginning, which is really for anything except for the dynamically created ones that get created down the lines, right? It's a bit confusing, I know, but once you take a look at the code and maybe review things for yourself, and you just keep with me, you'll eventually get it. So let's just do a vim diff now. We've now got an LV2. Actually, before we do that, let's actually take a look at what LV2 looks like. I believe it's really just the same thing, only the code is a bit more streamlined. So now we've got LV2. We have an UI file now with LV2. And really, instead of doing everything in the signal factory, we're using an UI file factory. And this is what we come up with when we are actually generating the entries for our list item. And so recall that with this GTK list expander stuff, the list item that we get is actually, right, a tree expander. And so that comes up there. And we then want to give the child type to be a label. And what property do we want the label to come from? Well, we want it to come from the expander string object. And so if we go like this, so within this C data UI file code that's generated from the factory, we are creating a tree expander with the ID of expander, and we're then telling it to look up the string of the item of the expander, right? So it's really the same thing as we did before, except we're now doing it with an UI file. And if we vim diff lv1.c versus lv2.c, let's go up the top. So the setup and the bind callbacks are gone, right? You see, because on the left we've got what it was before, and on the right we've got what it is now with lv2. So all this code can now be deleted. This is all the same. The create factory again can now be deleted because that's being done in the UI file now. We just deleted this comment because it's just obvious now what it does. That's not a big deal. And then, as opposed to creating a list view, because we've done that in the UI file, we're now setting up the list view with some code. Because, like I said before, you can't really instantiate a tree list model within a UI file. It's got to be done in code. And so we're keeping the same code here. We're just deleting some of the comments which we no longer need. The factory and the list view are already there. So we don't need to return a list view. We don't need to do things that way. Instead, we just use this helper function now to set the model of the list view to what we just to the selection model that we just created, which is the if I scroll over here, the tree model, a single selection model based upon the tree model. Instead of returning a list view that we're creating with a helper function, we're just setting the model of the list view to be the selection model that we're creating based upon the tree list model. So that's the only difference there. And then really in the activate, we've got different boilerplate code to create the window, etc., because we're now using GTK Builder as opposed to doing things all in code. Other than that, it's the same thing. So really not much else to see there. It's just we've cleaned up the code and we put more into UI files than we have in the C file, right? So now let's take a look at the third version. And now you'll see we have something totally different. We've got a list of all the letters of the alphabet in alphabetical order. And then when you expand the tree, whatever you call them, the tree expanders, thank you. You then get a list of words that all start with that letter. Now this is actually a better way of illustrating the usefulness of tree expanders, because before we were using fixed data, which is kind of pointless really, because if it's fixed, if the data is fixed, the data is fixed, and you should probably not use a tree list model. You should just use a list box or some kind of other data structure. It doesn't really matter. But if it's dynamic, which it is, because what we're now doing is we are parsing the file on our computer at user share dict words, and you'll find that most Linux distributions just have this file. Just a huge list, 38,000 lines of words, really. That's all it is. And we're organizing them by letter of the alphabet. And that's what LB3 is. That's what that demo does. You will probably find there's a lot of errors showing up on the terminal. I believe some of those were bugs in earlier versions of GTK. I'm using a really old version of GTK 4.4 on this machine to show this demo. So I think that in newer versions of GTK you probably won't see some of those errors on the screen. But there you have it. That's really what that demo does. So what does it look like? Well, let's see if we can do a vim diff between lv2.ui and lv3.ui. They're actually, you're off the hook. They're exactly the same thing. You see how it says 46 lines, and then there's nothing? That just means they're the same thing. So, all right. So then the differences all must be in the code. So let's take a look at lv2.c versus lv3.c. Okay. So lots and lots and lots of differences. So it probably may make more sense just to look at the new file. But you can see here, to get a bit of a sneak preview, we're defining the words file to be user shared dict words. And then we're doing a whole bunch of crazy things in order to create the widgets and to instantiate them. So let's take a look at lv3.c. So let's start from the main function. Everything's the same there. Everything's the same there in the activate function. We are setting things up. Then we have the UI file as we did before, but now it's lv3. Fine. Okay. So you'll note, though, we now have a different list model, tree list model creator called words list model creator. So why don't we go ahead and take a look at that? That's really going to be, I think, where the meat and potatoes of the differences comes in here. So like I said before, we've defined the words file as a macro there. So we're still going to create a string object as our base object type. And now, if if there is no string object, so we're grabbing the object, or rather we're grabbing the item, and if it's null, right, we're then going to simply create, we're then going to create letters A to Z, and that's going to be the whole of the string that we're adding to the list store, right, that we're returning. And actually, yeah, you see, one little thing, you see, this is why, in a way it's good, in a way that it's bad, that it's been so long since I've written this code. You'll know that this function is used twice in the setup list. We're recycling code. So the first time that we do it, right, we're making the point of passing null to it twice, and that will then go ahead and cause it to instantiate the A to Z list. So the first time that it's run. And if it then goes ahead and again calls itself when it's creating a list model, if any, right, based upon the data that we have, if the length of the string is 1, i.e. if the previous not column, but if the previous iteration of what was in the tree expander is 1 letter long, then we know it was one of these A to Z guys, right? And so we're then going to go through this branch of code, and we're then going to create a static string called contents, and we're going to create a static array called lines. So if it's the first time we've ever run this function, it's well defined that the contents and the lines will be initialized as 0 or null. And so if contents is null, it's going to then go ahead and grab the contents of the words file and put it into memory. And it's then going to create a string array by splitting the contents of that string into an array called lines. And then it's going to go ahead, assuming if it's either the first time this has ever been run or subsequently, because contents will then exist because it's static, and then it's just going to jump to this portion, or it's going to move on to there after it has created the contents for the first time. It's going to go through, iterate through the lines, and it's going to grab the first letter right there of the of the string, right? And if that letter then matches with lines I, right? So the if the first letter of the string we've gotten from the whole array matches, right, with the letter that we are on for the column, so A to Z, then we're then going to add the word to its own list store that corresponds essentially with that letter, right? And we're going to do that in a loop, right? And the store is going to then be added to in a loop until we've gone through all of the iterations of that letter. And if this else clause basically says if it's none of those things, like if basically we're either in neither nothingness, so nothing's been created yet, or we're not in a situation where we're in an A to Z string, that would therefore mean that we're in a word that's longer than one character, and so then we're then at the end of the line. So basically, if it's reiterating over itself and it's a full ass word, it's going to return null, and you're not going to then keep being able to expand that. And then otherwise, it's going to return a reference to whatever list store it happens to be. So there's multiple possibilities here. That list store could be an A to Z, i.e. the letters, or that list store could be full words that correspond with that letter, or it could be nothing. But I guess we've already kind of covered that there in the null. So it's going to cover one of those two possibilities. So that's really all. I don't want to say that's all that there is to it, because that was not exactly super simple, but really it's the only change from the last time. And again, if it didn't make too much sense to you, just review the code over and over and over again until it does. It's all in the GitLab repo, and again, feel free to experiment with it, change things around, see how you can break it, how you can make it different. That's what this is all about. And so again, it looks like this. Again, you've got the A to Z letters, and then you can expand it, and it gives you the words that correspond with that letter, but there's no other expansions. And that was why we got into those tests for whether to generate a list store or not. So then, last but not least, we've got LV4, which is actually the same thing as the other two, except we now have a search bar. And so let's see. Let me give maybe a good example. Let's go to Z. So we've got all these words here, but what if we only want to show ones that have the letters ZEA in them? So what we can do is click the search guy and type ZEA, ZEA, and then now you see it's only showing those words that correspond with that. And then Y is showing all these letters, you expand them, nothing's being shown. We could do just EA, and then now it's showing these guys that match in the W, these guys that match in the Y, and it's showing these guys that match in the Z, right? So, we've actually created a somewhat of a useful tool here, okay? So you see how things can come together. And if we expand the M, you're probably gonna get words like, well, I was gonna say words like meager, which is true, but mainstream also matches because you got the EA in the end there. So that's all good. So let's take a look at LV3.ui versus LV4.ui. And we do have some differences now. Slight thing we needed to do here. I noticed in older versions of GTK, such as the one that we're running, you can't use a combination. So we've had to add a child type of a title bar so that we can then go ahead and add our search button there. But in older versions of GTK, the only way to do that was to do child type is equal to title bar as opposed to property name is equal to title bar. And I noticed that in older versions of GTK, you can't use a combination of that child type equals and then property name equals child. So we had to actually go ahead and change this tag here to just a full child tag. But note that in later versions of GTK, and if you're targeting later versions of GTK, it's better to use property name equals title bar for the to craft your title bar at the top that has your search bar in it, and it's better to use property name is equal to child for the actual base child contents of the window. But yeah, you'll notice that in this version we've got a toggle button which has the icon of the search button, and the child here right. So we actually use GObject bindings here in order to say whether or not the search mode is enabled, right? And so what we do is we say the source of that binding is the search, the instance, like the object rather. The object source that we're looking the property up in is the search button. And the property of it is active. And it's a bidirectional binding, meaning that search mode enabled and whether the search button is active go together. And so if one is true, the other's true, and vice versa. So that's what the bidirectional property binding means. And then you've got your scrolled window there with a lot of the same items that it had before. And where I think we may be confusing ourselves a bit here with some of the diffed changes. So again, take a look at it in the GitLab repo to see what the differences are. But let's take a look at the code difference though. So we don't have as many changes this time around, but we do have the search entry widget, which we've got defined at the top there. We do have I don't remember what this is. Why do we have a return here? I think the reason is that in the older version, we didn't need to return until the end. Yeah, because let me take a look at LV4. You think that I didn't write my own code here the way that I'm confused over it. It's not that it's confusing, it's just that it's been so long since I've looked at it. Right, okay, yeah. So because now we've added this filter model guy, right? And so we have two different types of models. We may need to return earlier, right? If we are just creating the A to Z, we do that the first time it's ever run, and we return early with just that list. But in the event that we are engaged in a search operation, so i.e. that could be with any word really. You can't search for the individual letter guys on the left-hand column, but when we're dealing with words that get expanded upon, right? And note that we're just returning a list model either way, and so that list model can be a list store, or in this case, it's going to be a filter model if we're dealing with a full-ass word. But either way, it's an implementation of a list model, so we can still use the same function to return either or. So I know it's a bit confusing, but it is helpful to know that. And so in this case, the first section of this code up here is easy. It's the same as it was before. It's the letter. We just return a plain list store in the event that we've got a single letter, we're instantiating things for the first time. But if we're dealing with a word, then we create a filter model. And that type of filter is going to be a string filter. And we're not going to create any special code there. We're going to use what's built into the GTK. We're going to use what's built into GTK in terms of functionality. And we've got a long comment here that explains what we're doing. And so we're going to bind the text property of the GTK search entry. So as you're typing in to that search bar, there's going to be a property. So let's say we type in ASDF. The text property of the search entry is going to become ASDF, right? And so we're binding that with the search property of the string filter, and this is all built into GTK. So it's actually pretty cool the way you can do this. And so I didn't need to do anything too special there. Like the vast majority of what we're looking at here is a comment that explains what's happening. So we're not using a bidirectional binding here because it's simply the text being typed into the search bar that's dictating what the property is of the string filter that we're searching. So you can't really do it the opposite way because you're searching based on what you're typing in. There's no need for a bidirectional binding there. And so the question becomes, do we use this property called gbindingDefault or do we use gbindingSyncCreate? And I find that it's a little less obvious whether you should be using one of those two versus if you're doing a bidirectional binding, you know you're doing a bidirectional binding, and that's going to be the way that it is. Sometimes I find that you sometimes need to start with gbindingDefault if you're doing a unidirectional binding and sort of test the waters with it a little bit. So in this case, it's not quite good enough. You need the gbindingSyncCreate because it needs to actually synchronize the source and target properties upon the creation of the initial object binding that's going in the direction towards the filter model. So what this comment probably means is that for this particular case, I tried gbindingDefault. It wasn't good enough, so I switched it to gbindingSyncCreate, and it started working. So to be quite frank, in my experience, maybe people are out there that are a lot smarter than me that just know, but I find that you sometimes have to start with gbindingDefault and move to gbindingSyncCreate if it's not really working properly. You can also do this. I mean, we talked about GTK expression before. This is a commented out section of code that shows you how you could do this as well using expressions. It would do the same thing. I think that I just found that using a straight up GObject binding was more straightforward, and I do think that in most cases, if you have the option to do one or the other, and there's no real reason to do it with an expression, just do it with a property binding, because it's a little bit more straightforward to do, especially in code. I think that in UI files, the opposite may be true, but let's not get into that right now. And the rest is almost the same, except that in this branch of the code now, like I said before, we're creating a filter model as opposed to a straight up list store, and we're returning that, but again, as a glist model. So either way, what GTK is seeing that you're giving back to it is a list model. Either it's A to Z, or it's the limited or unlimited, depending on whether there's a search or not a search, list of words. And so really, that's how it all works. So if we launch LB4 again, just to illustrate one more time, now that we've gone through that whole explanation, right now the text, right, of the search bar is just null, and so it's not the search property that's being applied to the filter model is null, and so it's just showing every word. Whereas if we do type some text in there, that text is now ZEAL, right, Z-E-A-L, and that gets bound to the search property of the filter model. And GTK is already smart enough, this is already baked into the libraries, to know, okay, well that means now that we should only return a list model that contains a subset of what matches, right, with that search item. And so the list model to populate any of the guys that are sub guys from these letters, we can keep going down. There might not be any, quite frankly. If we just did these three letters, and you're now seeing more coming up because there's more matches with these letters, right? But pretty cool stuff if you think about it. I know that's pretty. It can be a bit of a head scratcher, but just know that what you're really doing is dealing with multiple different types of list models, and so you may need to go to the documentation. So, for example, here, filter list model, to get a little more information on that particular object type, and now it's going to tell you that it's a list model that filters the elements of the underlying model according to a filter, and I might need to actually go to so where did I search property of the filter. Oh, right. It's not a property of the list of the filter list model. It's a property of the GTK string filter. Yeah, there we go. So that's the search property there. So wow, the string filter, right, is, yeah, the string filter is what is passed to the filter list model constructor, right, along with the actual list store, to then create this filter model. So the property of the string filter, you can see right here, it does have the search property, and that's the search term that then gets used to filter things out. So you might need to go ahead, I mean, there's only so much time I have in these videos, I can't explain every single line of code, but study it up, and you might want to go ahead if you're confused, break things down, right? Look at the documentation for each object type and understand how they all connect together. But I think that is a good place to stop. Like I said before, all the code is on the GitLab repo. It'll all be on the show notes. It's not easy, and I think that you could probably tell that even I tripped myself up a number of times when I was trying to walk you guys through this. Again, a lot of that was a function of it's just been so long since I've written this code, but it's not easy, and I'm not saying that there's anything wrong with the way that these APIs are designed. I don't think that that's the case, but it's just that it does involve some pretty complex concepts, and it's not always easy at the outset to wrap your head around it. And again, you might think, why is it so complicated? Why can't you just tell it, like, okay, column 1 is this, column 2 is that? But the thing is, right, you might need to, and in this case we are, generating this data on the fly. You might not know how many columns are going to be created. So it kind of makes more sense to say, create a list model of sorts as you go down the columns or as you go through the expansions, and then you tell me when to stop. And so that's the way that it does work. And like I said, you're not stuck with any particular type of list model that you're using when you are dealing with this stuff. This one function that we wrote, right, returns more than one type of list model depending on the context. And so yes, it's complicated, but it's also powerful. And hopefully that is evident based on what we've looked at. So any questions, please feel free to write in the comments. I know it's confusing. Also, make sure to cross-reference the documentation and just study up on this stuff, and eventually it will make sense. I hope that helps. I don't think I'm going to create any more videos based on this list model, GTK expression, and list view stuff. I think if I do create more videos, I'll move on to a whole other topic, or what I might just start doing is just end this series and just maybe do some one-off streams from time to time, because I'm kind of running out of spare time to create these videos. So this will probably be the last video that I create for a while. Thank you for watching. Good night and good luck.